So an oil spill is increasing in size at a rate of 20 meters squared per minute, and we want to find out how fast is the radius of the spill increasing when the radius is 5 meters. Okay, so we have the radius and area that needs to be connected. So we can connect the radius and area through the formula. The area of a circle is equal to pi r squared. Okay, so we need to identify the relationship. We have a formula. Okay, so what have we been given here? This here is we've been given the change in area over the change in time is going to be positive 20 meters squared per minute. And we've been given the radius value. The radius is r is equal to 5 meters. Okay, we need to figure out the change in the radius. How fast is the radius? So we need to find dr by dt. That's our unknown quantity. So we're going to then go ahead and differentiate this expression. So I'm going to differentiate with respect to time. So I get the change in area over the change in time is equal to, I'm going to differentiate this, it's going to be 2 pi r. And then because we're differentiating the r function, we need to differentiate r with respect to time. We need to apply the chain rule. So I get dr by dt. Okay, that's the piece that we want. We need to know the area, the change in area, the change in time, and the radius. Well, we have both of those, so I can just plug it in. So this is fairly straightforward. I'm going to put in 20 meters squared per minute is equal to 2 times pi. Well, we want to know when that's what's happening when the radius is 5 meters. Okay, and that's going to be times by dr by dt. We need to solve for dr by dt. We're going to divide. So we end up with 20 meters squared over minutes divided by 10 pi meters. So the meters cancel out. And then we have in the denominator the minutes. Okay, so again, I'm keeping track of the units. You don't necessarily have to do this, but keeping track of the units, I have all these units kept together, and then I just simplify the numerical parts, and that'll give me the dr by dt. And the units do work out. So notice that the units work out to be meters per minute. The radius is meters per minute. So it's going to be 20 divided by 10 pi, so 2 over pi meters per minute, and that's r dr by dt. So it's changing at approximately probably about 0.6, somewhere around there, meters per minute.